Greetings, welcome. So in this lecture, we're going to be talking about the exponential function. And so I actually want to give you kind of the words for these. So if I write the function f of x equals e to the x, there's a name for this, and this is called the exponential function. And then if I'm looking at this over here, right? So if I take the function g of x equals the natural log of x, this also has a special name. This is the natural logarithm. So sometimes you'll hear people calling them these, and so it's good to know what their official names are. And I've mentioned before a number of times that a lot of how I think about the natural logarithm function is by its relationship to the exponential function. And you're going to be dealing a lot with these functions because a lot of things grow. So as we're in a pandemic right now, you're probably hearing a lot about exponential growth. A lot of things grow exponentially. Things like interest compounds exponentially. Like if you have interest either in your, like on your bank account or something like this, the growth within your account is exponential. Also, though, if you have loans, right, it's good. They're going to get bigger because of exponential growth. So it's a really important thing to understand exponential growth because it shows up in a lot of places. I like to say that a lot of why there's such high credit card debt and stuff like that is because people don't understand exponential growth. And that's a negative side to it. A positive side to it is that you can grow a lot of money by putting money into an account or something that has a good exponential growth. Okay. So because you're going to be dealing with these a lot, I thought it was worthwhile to spend extra time on them this week. We've talked about that before. But in particularly in this lesson, I kind of want to highlight some of the relationships and so on that you've already seen me using a certain amount. Okay. So let's just kind of go through them. So the first kind of one that's, you know, like a main relationship here is that if I have, so y equals e to the x, and I'm going to use colors with really high contrast so that's easiest to see what's going on. This is going to be the same thing as having that the natural log of y is equal to e to the x. And then just kind of switching the variables in here, that's going to be the same thing as saying that if I have y equals the natural log of x, this is going to end up being the same thing as having that e to the, this should be e to the y equals x. Okay, so you can see that I'm just switching around notation here, but it's kind of, you know, I'm doing this to highlight if you're starting, because these are actually equivalences. So if I have this, I have this. If I have this, I have this. Okay, so these are actually equivalences. Okay, so swapping the x and y, you get from this equivalence to this equivalence, but I'm just kind of highlighting the fact that if I start with this, I know that this is true. If I start with this, I know that this is true. But I'm really just swapping notation. These are the same equivalents. You're not crazy. That's what's going on. Okay. So another one that's really good to know is that I have the natural log of e to the x, that this is going to equal x. So in some sense, these undo each other. They're inverse functions. Okay, so this happens for all x. Okay, and this will make sense. So you know that you're not allowed to put negative numbers into the natural log, but this is fine because e to the x is always positive. Great. And then we also have for, okay, so now for this one, we have to have special conditions because I want to take e to the natural log of x. And as I just said, to stick something into the natural log, it needs to be positive. Okay, but as long as it's positive, I actually do get out x again. So these are inverse functions on their domains. They undo each other. Okay, so this is for all. And this is going to be x greater than 0. Okay. Now, let's just kind of do some examples. This is kind of good practice, so we'll do this. So some examples. I guess over here I could write some rules. Okay, and here are some examples. So we're just going to kind of go through these. It's good to see a whole bunch to kind of get all of your confusion sorted out. So I'm going to take, if I take the natural log of e, and then I put a squared here, then I can look back over here. So the natural log of e to something I should get out of 2. Okay, so this is 2. And then we'll do another one. So I used here rule 3. We'll do another one. And then I'm going to have, what happens, is it okay? Can I put in, so let's do e to the minus 1. So this is like 1 over e. That still works exactly using rule 3. So this should give me out minus 1. That's okay. It doesn't matter that this is negative. I'm allowed to do that, right? Because I can put a negative number into the e, like the exponential function. It just means it's kind of like 1 over e to that power. Okay? So this is, again, rule 3. It's okay with negative numbers. Okay? And then we have, oops, let's be consistent. Okay, so for C, I want to take the natural log. So this one, and maybe I'll actually highlight this for you. What I have going on here is that this is 1 over e. Okay? So sometimes we take the natural log of 1 over something, and it helps to just write it as an exponent like that. Okay, now we're going to take the natural log, and there's a reason I was just showing you that, because I'm going to write the square root of e. Okay? And this is another one of these ones. We have to remember how that works, that I have to take the natural log of e to the 1/2. Okay? But now, oh, great, here's my 1/2, and that's what I pick out. So this is just another complication with using this rule. One is if you have like 1 over some power of e. Another one's where you have something like a square root. But this is exactly the same kind of property. I'm just going to get out 1/2, and I'm still using rule 3. Okay. Now, let's try something else. So what if I take something like the natural log of e to the sine of x? Okay. Again, I can use rule 3. Okay. So I'm just kind of showing you all the different things that you might ask. Can I use it in this circumstance? Yes, this is totally okay. It even works for a function there. Okay. So this is, again, rule 3. Right? It works for negative powers. It works for things like square roots. It also works for functions. Okay. Now let's try. So that's kind of, we've kind of dealt with a lot of maybe the trickier aspects of rule 3. So let's try a new rule. So let's take e to the ln of 2. So we check over on our rules, and that one is rule 4 is going to tell us what to do, which is that I just get out the 2. And this is okay, because now there are restrictions here, but 2 is a positive number, so that still works. Okay. And then this also works, just like this one, like rule 3 works with functions, so does rule 2. So let's go ahead and do that. So we're going to take e to the natural log of, and then I'm going to stick a function in here. So I'm going to take x squared plus 1. And I can still use rule 2. It's okay that I stuck a function inside. Okay. Let's do the other 2 over here. So now I want to take e. So this one might look too tricky, but, you know, it looks not too far from something else that we might want to do. Okay. So this is going to be right? So something that we know about the natural log, though, is if I have a number in front, I can bring that inside to the power. Okay, so I'll show you what I mean. So this is the same thing as e to the ln of 2 cubed. Okay, so let me just kind of highlight here that this 3 ended up giving me a power up there. Okay, but that's okay. This is how the natural log works. And now I'm able to use this rule here. Okay, so this is just going to equal 2 cubed, or, right, so I can say that this is e to the ln of, and now I can say, okay, that's 8. 2 cubed is 8. I take 2, and then I double it, and then I double that, and then I get out 8. Okay, and then I can just use, this is not hard for me to see now that this is a rule for circumstance. Okay, so again, I'm just using rule 4. Okay, and then finally I have, so for h, I have, so what happens if I do this slightly differently? So what if I take e to the 3 ln of 2? Okay, and then another thing, right, so what's another way that we could think of this? What happens when you have a product in the power like that? So I'm going to end up getting another way I could write this, and I'm just going to show you I'm going to get the same thing if I did this. So if I took ln of 2, and then I cubed it, okay, we can do that when we have a product in the power. It doesn't have to be the exponential function. We can do that for any power like that. When we have a product, it turns into an exponent. And then this inside of here is going to be 2 cubed, which is 8. Okay? And so it's really noteworthy that these are the same. Okay? We're just kind of emphasizing that, you know, mathematics is consistent, right? I can use different rules and orders of doing things as long as they're both allowed, they're going to give me the same output. Okay? So looking kind of back at what we did here. So these are these rules. So the first thing is that these are inverse functions. And so you can think of them in terms of, like, if you swap those, that you get the other one. And so this, I find this very useful in dealing with logarithms, really, that you can switch it back to the exponential function. They also undo each other. These are all really properties of the fact that these are inverse functions of each other. Okay, so kind of looking at the rules. So some of the highlights here, right, is that this works with negative powers. Okay, so it works with negative powers, or if you have an exponent on the bottom. So if I have negative powers or an exponent on the bottom, okay, this works with fractional powers is what we're kind of seeing here. And then they work with functions, okay, in the exponent. And in fact, this, you know, the rules still work with these, that the fact that this one shows up here, that also shows up here, okay? So this is actually really good to know, is that you can actually, and then this one is that I can use different rules, but as long as I'm using them correctly, I'm going to get the same output, okay? So these are very useful. They're going to come into play a lot. It's good to get used to them, play with them, and make sure you're kind of comfortable. And so I hope this was helpful and made some sense, and spend a little bit of time with it. And I will see you in the next lecture.